Now in this question, a matrix A is given of order m cross n. Okay, and it is also given that m is greater than n, which means m is not equal to n. Okay, now if m is not equal to n, that is number of rows is not equal to number of columns, then A is not a square matrix, it is a rectangular matrix. Okay, now we know that we can calculate the inverse of only square matrices. So inverse of A matrix and transpose of A matrix is not possible. Okay, now it is also given that there is a matrix A plus, which is equal to A transpose into A whole inverse into A transpose. Okay, now we cannot move this inverse inside the brackets. Why? Because we cannot calculate the inverse of A transpose and A individually. Okay, then what we will do? We will see this term A transpose into A. Okay, A transpose will have an order of n cross m because rows and columns get interchanged, and A will have order of m cross n. Okay, now the product of these two will have order of n cross n. So this here forms a square matrix. So A transpose into A will form a square matrix, so its inverse is possible, but individually I cannot calculate the inverse of A transpose and A. Okay, so let's say there is a matrix X given by A transpose into A, and it is of order n cross n and is a square matrix, so its inverse is possible. So A plus we can write as X inverse A T. Okay, now we will see each option one by one and then check which of them is false. Okay, first we will take option A. In this option, A plus A equal to A is given. We have to check whether this relation is correct or not. Okay, now we know that A plus is X inverse AT, so we will put that here. It will be X inverse A T into A. Okay, now what is A transpose into A? A transpose into A is X, so we can write A X inverse into X. Now X inverse X will give me what? It will give me identity matrix I. Okay, and any matrix into identity matrix is nothing but the matrix itself, so it is equal to A. This statement is correct. Okay, or this option is correct. Now we'll move to option B. In option B, the relation is given A plus whole square equal to A plus. Okay, we can write this as A plus into a plus. Okay, now what is a plus? A plus is x inverse into a t, and again a into a plus is again x inverse into a t. Okay, now this a transpose into a is again x, so it will become a x inverse into x inverse into a t. This will be identity matrix, so this will be a x inverse into identity matrix will be again x inverse, so into a t. Okay, now what is x inverse into a t? It is nothing but a plus, so this will be a plus. So this option is also correct. Now the next option is a plus a is equal to identity matrix. Okay, now what is a plus? It is x inverse a transpose into a. What is a transpose into a? It is x, so x inverse x will be equal to identity matrix I. Okay, so this option is also correct. Now we are only left with option D. In option D it is given that a plus a is equal to a plus. Now we have already proved that a plus a is equal to a, so option D is wrong. So option D is the false relation. Okay.